This is Pre-Calc section 6.3, part 3, Solutions of Linear Systems by Row Transformations. And what this video is going to cover are the special cases you might encounter when you try to solve by reduced row echelon. So it is possible to have a system with either no solution or infinite solutions. And how you'll know is this. Whenever a row of the augmented matrix is 0, 0, 0, and here's our slash, A, where A is some number other than 0, then the system is inconsistent and there is no solution, like this. I have 0, 0, 0 here in front of the bar. I have a non-zero number right here that tells me there is no solution. Whenever the row of the augmenting matrix is 0, 0, 0, 0 all the way to 0, then the system is dependent and there are infinite solutions. And then you will need to write your solution in terms of z. So here's an example down here where the bottom row ended up all zeros. We know that the system is dependent. There are infinite solutions, but then you need to write your solution as an ordered triple in terms of z. So here are two examples. Here's my system. I've already put it over here in the original augmented matrix. We know we want a 1 in that first upper left corner position, so I'm just going to copy that right on over here. And we've got to create zeros in these two positions, and our ways to create 0 will be to multiply this by -1. If I multiply this by -1, this entry will be -1 plus 1 will give me the 0 I want. So symbolically, this is -1 times row 1 plus row 2, and I'm going to put that in row 2. So -1 times 1 plus 1 is 0. -1 times 2 is -2, plus -2 is -4. -1 times 1 is -1, plus 3 is 2. And -1 times 4 is -4, plus 1 is -3. I want to get rid of the 2 in that position, so let's multiply this by -2. So symbolically, that is -2 times row 1 plus row 3 going in for row 3. So -2 times 1 is -2, plus 2 is 0. -2 times 2 is -4, plus 4 is 0. -2 times 1 is -2, plus 2 is 0. And -2 times 4 is -8, plus 9 is 1. So here's the situation. We have zeros leading up to the bar and a non-zero number after the bar that tells me no solution. That's it, I'm done. Two comments. One is this row with a lot of the zeros does not have to be the bottom row. That's just coincidentally how this one worked out. It could be in the middle. Also, the last two problems you've seen, this last number has been a 1. It doesn't always have to be a 1. It just has to be a non-zero number. Next example, there's my system. I put it in the matrix already, and we know that we need a 1 in this position right here. And I can get it very easily by interchanging row 1 with row 2. Row 1 interchange with row 2. So my top row now is 1, 4, -2, 8. The middle row is 2, -5, 3, 1. The bottom row stays what it was. So there's my 1 in the top row. That is the row I'm going to use. So that is the row I come down here and I write again. And I'm going to multiply that row the first time through by -2 because that will create a 0 in that position. So that is -2 times row 1 plus row 2 going into row 2. So -2 times 1 is -2 plus 2 is 0. -2 times 4 is -8 plus -5 is -13. -2 times -2 is 4 plus 3 is 7. And -2 times 8 is -16 plus 1 is -15. I need to do that same step, but this time I want to cancel out the 4. So I will use -4 being multiplied through row 1. So that is -4 times row 1 plus row 3 going into row 3. So -4 times 1 is -4 plus 4 is 0. -4 times 4 is -16 minus 10 is -26. -4 times -2 is 8 plus 6 is 14. And -4 times 8 is -32 plus 2 is negative 30. So I've got my 1 in the upper left-hand corner and zeros below. Now would be the time to get a 1 in this position, but the only way I can do that is to divide everything by negative 13, and I'd really rather not have fractions. But I do notice something here. I notice that if I multiply this row by negative 2 and add it to the bottom row, a lot of stuff cancels out. So that is negative 2 times row 2, add it to row 3, and put that in row 3. So negative 2 times 0 is 0, plus 0 is 0. Negative 2 times negative 13 is 26, plus negative 26 is 0. Negative 2 times 7 is negative 14, plus 14 is 0. And negative 2 times negative 15 is 30, plus negative 30 is 0. That's important. If I have the whole row being zeros, that tells me that this is a dependent system. Now, I have to solve that system in terms of z. So I've got to go back and write my first row and my second row as is. It was only when we got to that third row being all zeros that we knew this was a dependent situation. And you're saying, how in the world do I know I have to look at that? Well, now that I've given you this hint, you need to look at that on any of these to see if any row happens to be a multiple of the other row, because then you can just multiply by the opposite sign and make this cancel out. So where do I go from here? I need to write this information as equations with the x, the y, and the z. You're going to be told to write your answer in terms of z, which means something, comma, z. So we're going to have to write expressions for x and y in terms of z. So this middle one gives me this, negative 13y plus 7z equals negative 15. I need to solve this for y. So subtract 7z from both sides. This is negative 13y equals negative 15 minus 7z. Divide everything by negative 13. And y is the expression positive 15/13 plus 7/13 z. That is my y expression. Now I need to deal with the top. X plus 4y minus 2z equals 8. X is x. We know that y is this binomial of 15/13 plus 7/13 z. Then minus 2z equals 8. Eventually I need to solve this thing for x, but I want to do some distributing and cleaning up first. 4 times this is 60/13 plus 4 times this is 28/13 z minus the 2z equals 8. Still need to clean this up. I've got 28/13 z minus 2z. You can use your calculator on that, and you can get 2/13 z. Then we have a plus 60/13 right here. I need to move it to the other side by subtracting 60/13 from both sides. And you can use your calculator on that, and that gives me 44/13. Now, if your calculator doesn't use fractions, then you're going to have to do this by getting a common denominator. This is 28/13 z minus 2z. Get a common denominator, which is 13. And 2 is the same as 26/13, and that's how we get 2/13. Same thing over here, 8 minus 60/13. 8 can be rewritten as 104/13. Minus 60/13 is 44/13, but the calculator is a lot easier. Now I just need to get x alone by subtracting 2/13 z from both sides, 2/13 z plus the 44/13, and that's my expression for x. So my ordered triple is the expression negative 2/13 z plus 44/13, comma, 15/13 plus 7/13 z, comma, z. You can put this in any order you want. Notice this happens to have the z in front. This one I happen to have the z in the back of the binomial. You may see on MathLab, instead of this being separated fractions, they may write it as negative 2z plus 44 over 13, and that's perfectly acceptable. Remember what this stands for. These are the expressions that will generate every solution. You'd have to pick a value for z. Let's say z is 0. If I put 0 in here for z, this would be 44/13, comma, put a 0 in here, 15/13, comma, 0. That is a solution to the original system that we started with. I could make up another number for z. I could do 1, 2, -2, whatever I want, and generate an infinite number of ordered triples that would be a solution to the original system.